Good morning, everyone. Welcome back. So yesterday we started discussing Terraform. Okay, so generally the universal concepts of we started with the universal concepts, that is like variables, data types, and then conditions, loops, and functions. Okay, and every scripting have some additional concepts. Here also we have some additional concepts that we will discuss. Those are simple. Okay. So yesterday we set up Terraform. We downloaded terraform.exe, we set the path, and then we are creating we are using Visual Studio Code as an IDE, and we are using terraform.exe, and we configured AWS credentials using AWS configure, and Terraform started connecting with AWS account and creating resources. Okay, so we updated the document here. So this is very important to understand the advantages of Terraform. Okay, so in concepts repository, so here we have Terraform. So first you need to create IAM administrator user and run AWS configure to configure the authentication. And then these are the advantages: version control, consistent infra to create the infrastructure same across all the environments, and then CRUD against infrastructure inventory, and you can do cost optimization, automatic dependency management. We saw this yesterday clearly while creating EC2 security group and modular infra, just like our Ansible roles. Okay, so these are the three commands: Terraform init, Terraform plan, Terraform apply, and Terraform destroy. So that's it, no other commands in Terraform. Okay, and yesterday we created EC2 instance, and then we used variables as well. Okay, so it's often best practice to create separate TF files. So you need to run Terraform command wherever you have .tf files, and very important, you should have .git ignore while working with the repositories, because this Terraform provider is a huge memory. Our GitHub is not intended to store the softwares, it is only intended to store the code. If you try to push this, then GitHub will reject your code. Okay, but anyhow, here we don't have any requirement to push it to the GitHub. We can directly run Terraform commands from here, but still you need to manage your repositories. So that is why you should have .git ignore in your projects also. Don't forget this. Okay. Yeah. So yesterday we started discussing variables. Just like in any other scripting language, we have number, string, boolean, and then list and map. Okay. So this is the list. List always starts with braces. It can have 0 to n elements. Okay, and then this is the string, and now let us see other things. Okay. Yeah. So this is our resource creation. Okay, the resource, and what is the resource type you are creating? This is very important. You should follow the Terraform documentation, and this one, it's your wish, you can do whatever you want. Okay. And we have security group also. So this is number. You can keep this. 1 second. Just 1 second. Yeah. So this is number. You can keep this in variable 2. Okay. So now let us work with other, that is map. Okay. So map here, it is just key value pair. Okay. For example, so there is something called tags feature. So while running instances, when you create instance, you will have tags. So tags is a universal concept again. Tags, very important, simple, but very powerful. Mostly for filtering and cost optimization, we use tags in AWS. Okay, tags is always key value pair. For example, what is the name? Name is very important in AWS. You can give name with this one, and should be caps. Okay, name, and you should give a name, your some name. Okay? And generally we give another thing, environment. Environment equal to either dev or QA, whatever environment. So by seeing the resource, we should understand which environment this resource belong to. And then Terraform equal to true. Terraform equal to true means if someone sees this resource in the console, they will understand these resources are created by Terraform. Okay, generally we give these resources and then like component, which component this resource belongs to. For example, MongoDB, cart, like that. Okay, and project, RoboShop. So generally these are the tags very useful for any project. So by seeing that resource, you can understand this resource belongs to RoboShop and this component belongs to MongoDB. This is created by Terraform and this environment is like dev or QA or production, and name of the resource is like this. By having these 5 tags generally, okay, you can easily find out the resource. Okay. So now these are the tags, right? So every resource will have tags, not only a single, every resource in Terraform will have tags. Okay. Here now we go to documentation of AWS docs, Terraform docs, and then Amazon Web Services. So it's okay. You don't find the path, you can directly search here. Terraform AWS instance. Okay. Yeah. So this is the TypeScript. No. Select Terraform here. Here, these are the options. Every resource will have tags option. You can just see here, tags equal to this one. So this is key, this is value. Okay. You can mention tags here while creating the resource. For example, you can mention here tags and create like this. Name equal to, what is this instance? For example, MongoDB. And then environment equal to dev. Okay. And Terraform equal to true. And then what else? Project equal to RoboShop. And then component equal to MongoDB. Okay. For example, I can create the tags like this. But instead of creating or hard coding here, you can just keep the tags in the map. For example, here you can keep variable tags, and this is the map type equal to map. Okay, and then default. So map will always have flower braces like this. Just keep the same values here. That's it. So this is the map. Okay, you can refer the maps, just tags equal to var dot tags. So that's it. Okay, now let us create the resource. Terraform session 1. So first command, Terraform init always generally. It has downloaded already, not a problem. Okay, after that, Terraform plan. So this will give us clear picture of what are the resources it is going to create, but it will not create, it will just give us the plan. It is creating two resources. One is security group and another one is EC2 instance. Now you give Terraform apply. Instead of saying yes manual, you can just give auto approve. Okay, by default, it will take it as yes. So started creating. Now you can come and check here. Okay, you can see the name is given. See the tags here. These are all the tags we have given. So tags is a best practice to follow properly. Okay. So we have all the tags for any resource, not only for EC2 instance, for any resource. So this is about variables and data types. Now we have some additional concepts generally like outputs. So variables is nothing but inputs, right? You are giving inputs to the AWS resources. But similarly, we have outputs. Now I want the public IP of the EC2 instance created. Generally, you go to the console and you take it, but I don't want to go to the console and then get. I can have for every resource, there are some outputs. When AWS is creating the resource, it is Terraform responsibility to fetch the outputs as well. Okay, so those outputs, here we have something called attributes reference. Okay, you can see. So these are the outputs. You can see exports. So whenever Terraform created the resource, it is able to fetch all these values as outputs. Now I want public IP. You can just give this is public IP. So what is the syntax? Again, it is very simple. Output and what is the name? Output variable name. And then flower braces. And what is the value? Okay. Value. So this is the syntax. So again, the same best practice, you can create outputs.tf. Here you mention output public IP. Okay. And then second. Yeah. Output here. This is the name and what is the value? Okay. Value equal to. So what is our instance? This is one type of the instance dot your resource name. My wish I can decide. This is the resource name dot. What is the reference? Public IP. That's it. Okay. Now it should fetch the value and then it will show it to you in the console. Okay. Now you apply again. Now you will get the IP address directly on the console. So this is useful, very useful outputs also to create another resources generally. So this outputs may be the inputs for another resource. Now you can see you got the public IP address directly on the console. So this is about outputs, very simple. That's it, nothing much. Syntax is also very simple. Output, name of your output and the value. Okay, and let us move on for the conditions. Okay, let us take conditions. So you know this very well. If general syntax, expression, and then if true, these statements run, and else these statements will run. Else means false. If false, these statements run. Okay, so this is multi-line if condition. In Terraform, you can have very simple, that is expression, question mark. This will run if true, colon. So this will run if false. Okay, so this is the expression, just like this. If this is true, this one will run. If this is false, this one will run. So this is also a condition. Okay, one line condition generally. So this is very simple. You can just get the documentation here, Terraform conditions. Okay. You can just check here. So this is the condition expression. This is true. This is false. Okay. So for example, so we have two environments, dev and prod. So dev, you want to have small instance like free trial t2.micro, or we have this real condition, right? If MongoDB, so we are creating t3.medium. Otherwise, we are creating t2.micro, right? So let us implement this condition. I'm creating here session 2. Okay, so this is a new folder. Again, you should have provider.tf. Provider.tf. So I'll keep this provider.tf. Okay, provider.tf is very important if you are working on in a particular folder. Now I'm just giving conditions.tf. Okay, so resource AWS underscore instance, and then just making it as conditions. So I'll create one variable, variables.tf. Here I'm giving variable instance name. Okay, instance name default equal to MongoDB. Okay, for example, this is the instance name. I'm creating resource, that is AMI. What is the AMI? And then instance type, right? For example, take this. So this is the AMI ID. Okay, you can take it from the variables. So this is the AMI ID, and here I need to give instance type based on the condition. Now you write the condition here, where dot instance name double equal to, for comparison, MongoDB colon, what is the instance? It is t3.medium. Okay, if false, you can give t2.micro. Okay, sorry, here it is. Here it is question mark. Okay, that's it. Where dot instance name If it belongs to, what's the syntax? Equal to question mark. Yeah. Instance type equal to where dot instance name. If it is equal to MongoDB, we are creating t3.medium. Otherwise, we are creating t2.micro. Mistake here. Need to remove colon after question mark. Oh, yeah. Yeah, this is the syntax. Okay. So now let me go to session 2. And then since it's a new folder, you can see. So you should always run Terraform init for the first time. So it is downloading the provider. It's done. Now Terraform plan. Okay, now let us see. The instance type is taken as t3.medium because this expression is true now. Now let us just change it to the cart. Now let us go for planning. No need to apply. In planning stage itself, you can confirm which expression is validating. Okay, you can see now it is t2.micro. So this is the syntax and the usage of condition. It is very simple. And the next thing is loops. Okay. So here we have three types of loops actually. So one is count and count index. Okay. Count and count index. So let me take another folder as count. Okay. I'll copy this dot Terraform because it is taking some time. Generally, you don't copy it, and I'll keep it here. Okay. Now I'm just marking it as count.tf. Okay. Copying the syntax again. So we have a requirement of creating multiple instances, right? So that is what instances we have. We have MongoDB, we have cart, we have catalog, we have user, we have Redis, we have MySQL, we have RabbitMQ, and shipping, payment, and web, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 instances. How to create 10 instances at a time? So you need to copy this for 10 times generally. Okay, so if you want to create 50 instances, is this a best practice? Definitely it is not, because you are duplicating the code. So whenever there is a huge part of code duplication, just consider it is not a best practice, and just confirm there will be a better option always. Okay, not only here, any scripting or programming language, if you see there is a clear duplication of the same code, then that is not a best practice. So that is why we have something called count. Very simple here. Just give it as count. Count equal to 10. Okay. So I'm removing this condition for now. Just making it as t2 dot micro. Okay. And variables. Variable AMI ID. What is the AMI ID? So this one. This is our AMI ID. And yeah. So now if you create, you will get 10 instances. Let us cd and then count. Terraform plan. Not running in it because I already, oh, Terraform init. Yeah, I need to create Terraform init. Because there is something called dependency log file. We will understand this later. Okay. Now go for Terraform plan. Okay. It is calculating the number of resources. Now it is saying 10 to add. So 10 EC2 instances it is creating. Okay, let us name it. For example, tags equal to name equal to RoboShop. Okay, and Terraform apply auto approve. Okay, 10 instances are creating in the background here. You can see, but all the instances name is RoboShop. So how can you recognize which instance belongs to which component? So every instance is showing as RoboShop. For that purpose, we have something called count.index. Terraform count. Let us go through this documentation. And there is something called, can give always count, and there is a special variable available count.index. Now focus on this. How can we improve it? Okay. So now variable, these are the instance names. Okay. What is the type? Type equal to list. Okay. And then default, you can mention the list here. What is our list? So this is the list. So these are the list of instances we are going to create, right? Just keep it as like this. And So these are the list of instances. So how can you make it better with count.index? Now let us see that. So this count is 10. And what are the index? Index starts from, you know that, right? You can type index starts from 1 or 0. So index always starts from 0 in any programming or scripting. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So now here you just name it as, how can you get it? Where dot instance names. Okay. And then here count dot index. So for the first time it is creating the instance, first it will fetch the name of this one, MongoDB, and second cart, and third catalog. So now the instance names will be perfectly set. Okay. So now let us apply directly. Terraform apply auto approve. Okay, now you can see 10 resources are getting changed. What are the changes here? Tags are getting changed. Now you can just check here. Okay, names are set. Now we have another thing. So if it is MongoDB, it should be t3.medium, or if it is MySQL, it should be t3.medium. So now let us implement that as well here. Instance type. Okay. So where dot instance name of count dot index is equal to MongoDB, or is always the symbol is like this, two pipes, or where dot instance names dot count dot index is MySQL. Okay, the instance name should be, instance type should be t3.medium. Okay, otherwise it should be t2.micro. So, okay, now a simple condition we are implementing. If the instance name is either MongoDB or MySQL, create t3.medium, otherwise go for t2.micro. Okay, so now let us apply directly. Generally, so you go for plan, okay, and you will see what are the changes instead of applying directly. Okay, now it is saying there are two resources going to be changed. So t2.micro to t3.medium, that is MongoDB instance, and MySQL is going to be changed from t2.micro to t3.medium. So now this is good. This is the expected result. So you can clearly go for apply. Okay. So now you can see this. So our MySQL is stopping, and then it will start with t3.medium. Similarly, our MongoDB is also stopping, and it will start with t3.medium. Okay, it may take 1 minute. So this is about the count and count index. So very important, we use this more frequently. And we will have for loop also, we will discuss it anyhow. And then let us discuss something on, okay, so let us implement our Route 53 as well. So you know Route 53 also. Route 53, there is something called Route 53 record. Yeah, so we need to create the record. So this is the Route 53 record. Okay. Resource and AWS Route 53 record, you can name it. Okay, I'm just naming it as record. Zone ID. What is the zone ID? Keep it in variable var dot zone ID. And what is the domain? Not this one. This is the record name. And TTL, I'm making it as 1. Okay, now we want to give the record either public or private here, or let us get the zone ID. This is Route 53. And this is our hosted zone. And from here you can get the zone ID. So this is the zone ID. I'm making it in a variable. So variable zone ID default equal to this one. Okay, you are referring the zone ID, and here record name. So similarly, you need to create 10 records. Okay, count equal to 10. Okay, var dot zone ID and name. So generally name is MongoDB dot, okay, MongoDB dot your RoboShop dot online, right? Something join DevOps dot online. So here var dot instance names of this one. Okay, dot join DevOps dot online. Okay, let me check. Okay, now let us try this. This should give an error. Okay, so anyhow, let us check this. It will give us an error. And what is the IP address here? Okay, so this is giving the, you know, we have output, right? So let us take the outputs. Outputs dot pf output private IP. Okay, value equal to, so AWS instance dot conditions dot private IP. Okay, so now you are getting actually 10. So you should get 10 private IP address here. Okay, let us just print for now, and then later we can check on this. Okay, first we need IP addresses. Now let us apply. There is an error. So it has the count set. It is a list. I'm just thinking it as a string. So in that place, you have to give wildcard expressions of star. So if you give like this, it means you are telling output, I need the complete IP addresses, private IP. Okay. Now Terraform apply up to. You can read this expression. Either you need to give particular index or you need to give star. Conditions. So for okay, let us just search output print list of IP address when count set Terraform. So that should be, yeah, this is correct. Colon star braces star But simple mistake here. Here you should set. Okay. Now you can see it is also telling us to set after conditions. So now we got all the private IP addresses into a list. Okay. So now here you need to get this. Here you keep it. Here you can give count.index. Count.index. Okay. So you will iterate this for 10 times, and then every time you will set the record mongodb.joindevops.online, and then you will set the private IP address. Okay. Now let us plan. Terraform plan. So as expected, here is the error. So in that case, generally double quotes, and then so we'll try this one. Okay. So when you are mixing the variable and the string, okay, so this is the string. So this is the variable. So when you are mixing like this, you need to give dollar and then flavor braces. So this is called as like interpolation, I think. And now it is trying to add 10 resources. You can see web.joindevops.online, payment.joindevops.online. So this one we call it as interpolation. Interpolation. You are mixing one variable and then one static string. So in that case, you need to give dollar places because you need to tell Terraform this is something different, not a normal text. If you don't give like this, what will happen? Terraform will treat this as a normal text. You can see the color also. Okay. Now this is variable and you are attaching static string to this variable. You can keep this also in variable. Okay. Now let us keep this in variable domain. Okay. Default equal to join DevOps dot online. Okay. Now you can keep it here. So again, dollar this braces var dot domain name. Domain or domain name? Domain. That's it. Okay. And now let us apply it. Just give yes. Now you can check our records will be created here. You can see all the records are created. Cart, catalog, everything created. So this is about the count and count index. Now let us discuss something on Terraform concept locals. Okay. Sorry, first we'll discuss functions. Terraform functions is very simple, and in shell scripting we were creating functions. Okay, and in Ansible we created customized functions. Those are nothing but roles, and the default functions, Ansible default functions, those are filters. Okay, but in Terraform you can see there is no user defined functions. So you cannot create your own functions. You have to follow the Terraform functions. Okay. For example, if you want to understand the maximum of this, you can create max of 5, 12, 11. Okay. Now let us just see Terraform console. Okay. Now you are in Terraform. So if Terraform console, if you type and if you see this greater than symbol, you are completely in Terraform environment. I am asking Terraform, what is the maximum of 10, 30, and 45? Okay, it is giving us the output 45. So for the function, remember this, either user defined or Terraform default functions or any standard functions, you have to provide the input, then the function will give you the output. So similarly, you can have min 1, 2, 3. So Terraform will give us the minimum value. Okay, so we have a lot of functions here. There are numeric functions. You can have maximum, minimum, and then something absolute value. Okay, and logarithmic functions and something floor. What is this floor? Closest whole number. Okay, and then yeah, these are the numeric functions and string functions. String functions are very important. We will use this anyhow. Okay, let us see the join. Okay, you can see this join separator and then list. I'm giving the list. I want this to print it as this one, something like this. Okay, and then yeah, let us try this. We will use it anyhow in our join. I want to join the list like this with the space, or at least space. You have to give list. Okay. Shiva, and then I'm giving Kumar, and then I'm giving It is something like this. Okay. Now I want the name to be with proper space. Oh, syntax error here. So I forgot to give brace. Control C, Control D, Control Z, not coming out. Okay, let me kill this. So this is just for demonstration. Okay, we don't use anyhow Terraform console. We will use directly inside the code. Terraform console. Join with space. We have a list of names. Okay, maybe the first name, middle name, and last name. Okay, so we have something. We received something like this. Okay, now we are asking Terraform to join these names, first name and middle name and last name as full name. Okay. So like that, we have a lot of functions available. Lower the case. Okay. Now, if you give lower of, sorry, lower of, we should close this place. Okay. Like this, and then you have something split, we use it. If you want to split it with this one, you can give comma, then it will give you the list. And we have file functions. This is also very important. If you want to read the content, okay, we have some use case for this. So, for example, I want to create EC2 instance, okay, with key. So, you know, we have AWS Linux 2 we created with the key. So you have to provide the public key. Okay, provide public key to the instance. So before that, you should create the key, right? Okay. So imagine I have some key pairs already. DevOps and delete. Second, create EC2 instance. Okay. So now I want to create public key. So what is the option here? Generally, just go and search key. You will have AWS key pair under EC2. You can just see this. Okay. I'm creating key pair first. So this is the resource. Okay. And public key, instead of hard coding like this, you can always use file module, or sorry, file function. You can see file like this. Okay. So here, let us keep our DevOps key. Let me get it. See users and then user. So I have DevOps public key here. Yeah. So this is the public key. Okay. Instead of hard coding in the Terraform, let me create DevOps.pub. Okay, I'm keeping it here. So I can use file function in the current, this is the current working directory, read this devops.pem. Okay, so you can give the name DevOps pub, for example. So while creating AWS key pair resource, I'm asking Terraform use file function, read the content from this and create the key pair. Now let us go for plan Terraform / DevOps repos Terraform count here Terraform plan. Sorry, it is pub, I think. Yeah, dot pub. Yeah, you should not keep private key in the repositories. You can keep public key. And now you can see it is able to read the file content using file function. Okay. Now you can create the resource or just Terraform apply auto approve. Now it will create the resource. Okay, we got the public key. Now you can use this key to create any instance. Now let me create one instance. provider.tf, you need to keep it. Let me go to locals and Terraform init. The provider.tf is mandatory to initialize Terraform. Now I'll create locals.tf, some file, and then test locals.tf. Okay. So here, let me remove the resources of the previous one. Terraform, destroy, auto approve. To approve. Okay, we'll destroy all the resources created. Okay, let it remove. Let me take this. Let me take this and improve it through locals. I need variables also. Okay. So here you can see there is something called this one. Okay. So you cannot mix two variables. For example, just let me show you. So the syntax is locals, and then this one here you can have variable name and value. Okay, you can have simple variable name and value. For example, let me give AMI ID here. So inside variables, I'll comment this. I'm keeping the AMI ID here. Just the slope. Yeah, yeah. So you can use like this locals, and inside here I will keep it as local.AMI ID. The syntax is here you should use locals, and while referring it as a variable, you should give local.AMI ID. Okay. So now this can work as a normal variable. Destruction is going on. Yeah, 22 resources destroyed. So now you can say go to locals and then Terraform plan. Let me remove this too. Terraform plan. Okay. So it is validating, right? You are able to get the AMI ID successfully from the locals. This is the simple usage as variables, but it has some extra capabilities. What are those extra capabilities is, I'm just giving it as let me keep this as well, and then copy this DevOps pub also here. So you can say this, I'm keeping it here. So if you want to create another instance somewhere in some file, anywhere in this folder, again, you need to write like this. So instead of that, what we can do here is we can cut it and then keep it here. Key, public key, for example, I'm giving it as public key. This is the variable, okay? And we can keep it here like this. Okay, so now this is the function. So locals are useful to validate the functions or expressions at runtime. Okay, so now you can use this local dot public key. So this name can be anything. Let me name it as key underscore public. It can be different name here, but you should refer the same name here. Local dot key underscore public. So the usage of locals is, this is an important question. What are locals in Terraform? Locals are like variables. You can have key value pairs, but it has some extra capabilities. It can have functions and expressions. So those will run at runtime and give the value. So now you can use this anywhere in your entire folder. Somewhere else, if you want to create another instance, but if you want to give the public key again, instead of writing this hard coding this file function here, you can simply keep it in locals and you can use it. So now let us try to plan. There is something wrong here. An input variable with name AMID has not been declared. Error is in 26. What is the error? How should I correct this? You can tell me. Now what should I keep here? Because I'm maintaining this in local, you can just give local.amid. Correct. Okay, now you can see it is properly validated. This is how you can use locals. And let me keep few other things also. So this is functions. So you can keep functions in local. Let me keep another thing, instance type. Okay. So here, instead of this one, so we have a condition, right? Where dot environment. For example, I'm creating where dot environment variable. Variable is production. For example, I'm giving this instance default equal to true. So is production is true. Now here I'll write a condition where dot is production. If this is true, then instance type is t3 dot medium. Otherwise, instance type is t2 dot micro. Okay, so let me comment this for now. Okay, only these two resources I'm working on. So where dot is prod, if this condition is true, so it means the variable we have already true. So the instance type should be t3 dot medium, otherwise t2 dot micro. Now let us try to plan. Okay, you can see T3.medium is done. Now I want to keep this inside local. You can just cut it here and then inside locals. So this is the expression. So it is locals are capable of running functions at a time and take the output into a variable, and locals are capable of validating expressions and take the output into a variable. Okay, now you can simply refer here where, sorry, local dot instance type. Okay. So even now it will work. So variables, normal variables are not capable of this. Here now you can see it is validated properly. Let me mark it as false. Means it is not a production environment. Now you run it, you should get t2.micro. Okay, t2.micro. So that is local. So this is very useful Terraform feature. Okay, Terraform locals. So local values assign a name to expression. So you can use name multiple times within a module instead of repeating the expression. So this is the expression. So this is the expression. This is the function. Okay, you can say like locals are like variables which can have key value pairs, and it has some extra capabilities of having the functions or expressions and take the output into a variable or name. So that is this one. So this is generalized answer. This is bookish answer. Okay. Yeah, you can see you can have functions here. Just like we had a file function there. That's it. This is about locals. We will also use it anyhow. So this is about locals. And we have another concept called data sources. Okay. So data sources, right now you can see we are getting the AMI ID from the console. For example, go to AMI here. I want to get AWS Linux AMI, AWS Linux 2 AMI ID. So what I do generally, I can come here. So this is the, generally this is the AMI ID. Okay. So this is the AMI ID. So AMI ID are frequently changing. Okay. It is not a guarantee. It is always the same. Whenever there is a new update, the AMI ID are frequently changing. And AMI ID is different for different environment. Okay. So every time I have to go to the console, I need to fetch the AMI ID. That's not an automation, right? So that is stopping me to complete the automation. So Terraform is giving us one thing called as data sources. So what is this data sources itself? By the name itself, you can understand. You can query the data dynamically from source. Here, what is the source? That is nothing but AWS. Okay, instead of fetching the AMI ID manually from the console from AWS, you can query the AWS to fetch the AMI ID automatically. In future, if the AMI ID is changed, not a problem, you'll get the latest AMI ID. And it will give you the AMI ID based on the region also. So let us see the Terraform data sources. Terraform data source. Okay. Data sources allow Terraform